joule I will write down here again, so that you will get the 4 marks. If you forget, write down over here, so unnecessarily it will in the 1 mark. Okay, so this is the first question, that is very easy. We are going to just apply this formula, potential, gravitational potential energy is mgh. So remember, always we take the vertical height, not the slanting height for this mgh formula. Calculate the now they here the question B here, the package is raised through the vertical height of 2.4 meter in 4.4 seconds. Here additionally the time is also given. Calculate the power needed to raise the package. So we are going to use the work power formula. Power is nothing but this work by time or the energy by time. So I will write down over here. So power is nothing but equal to energy divided by time. So we know that the gravitational potential energy we are going to consider here. So gravitational potential energy that we already calculated, that is nothing but 864. So here 864 divided by time taken is given, that is 4.4 seconds. So 4.4, and we are getting the value of the power is nothing but around 196 watt. So we know the unit for the power is watt, so I will write down here 194 watt. So this is another simple problem. We can say firstly we'll calculate the gravitational potential energy. Here we calculated the power. Now the C question is this: the electrical power supply to the motor is much greater than the answer in B. Okay, so here we calculated the value of around 194 watt, but the actual power given is much greater than this answer given in the B. They explain how the principle of conservation of energy is applied to the system. So see here what happens when the conveyor belt is going from here to here, and if you are going to supply this much power, within this much time it is expected it will go up, but what is happening, we are going to apply more power, and still how the principle of conservation of energy is taking place. So it is actually always it is taking place, but practically some amount of energy is always converted into some other form of the energy. So principle of conservation of energy is always there. So we can write down here some energy that we are going to provide at the beginning is dissipated into the surrounding okay, or you can write down in the form of heat, namely in the form of the heat, and some energy is dissipated, but it does not mean the total energy conservation is not there, but we can write down the total initial energy is always equal to final energy. Okay, so the energy conservation law is always there. Okay, you can write down either in the word or expression, any way you can write down, but the total energy is always there, but some amount of energy is dissipated into the surrounding in the form of the heat. Okay, there are other forms of energy as well, like sound, friction, etc., but the main is the heat, and you have to write down always the heat, or you can write down the thermal energy. Okay, that is the most important keyword to get the 2 marks for this question. Now last question is that assume that the power here available to raise the package is a constant. So we are assuming the power is a constant here, and the package of the mass greater than 36 kg is raised through the height, and suggest and explain the effect of this increase in the mass. So we are going to increase the mass, so what operation on the operation of the conveyor belt. So what is the impact and what is the operation of the conveyor belt? So we are going to increase this package mass, and power is constant. So power of the motor is constant, only the package is more. So what would be the output, what would be the impact or the effect on the conveyor belt? So first of all I will write down here so power formula, we know that is nothing but energy divided by time. So we know that energy divided by time here, it is the first important thing, and as can write as the mass increases, increases, the gravitational potential energy, right now gravitational potential energy also increases. Okay, as the mass increases, the gravitational potential energy, you can say that is also greater, and there will be the increase in the gravitational potential energy, because here E is nothing but mgh. So if you increase the mass, of course there will be the greater potential gravitational potential energy. And as the P is constant, you can say as the P is constant here, so if I take P constant, energy will be directly proportional to the time here. Okay, so energy will be directly proportional to the time here, and so we can say here more amount of work is to be done, more amount of work needed to raise to same height, because energy is nothing but the work and energy is directly proportional to T. So more amount of energy is needed, more amount of work is needed to go to the same height, and as the power is constant, we can say the time will be more, time taken will be longer. So time taken to reach the height will be longer. Okay, so here the P is constant, and as I will show it over here again, so P will be equal to, here P will be equal to energy divided by time, and as the P is constant, this is constant, so I can write down T will be coming to the left hand side, so T will be directly proportional to E, and E is nothing but mgh here, E is nothing but mgh. So if m is increased, the mgh will increase, that means T will increase, that means the time taken will be increased. That's why I have written over here. So as the P is constant, more amount of work is needed to raise the height. More amount of work means more amount of energy. Okay, that is nothing but more amount of work. So energy is more, that means time taken will be again more, because time and energy are proportional to each other, because power is a constant. So this way you can write down the answer to get all the 3 marks. Okay. So now we are going to the next question. Here the second problem, you can see the electric train is initially at rest at the railway station. The motor causes a constant force of this force is given over here 360,000 Newton to act on this train, and the train begins to move. To state the form of energy that is gained by the train and begins to move. So which energy is gained by the train? As the train is moving, that means it is having some motion, velocity, and whenever there is a velocity, we know the kinetic energy, because it is nothing but half into mass into velocity square. So we can write down here the kinetic energy. Train gains the kinetic energy as it starts moving. Now the B part here, the train travels a distance of 4 kilometers along the, here you can see the straight horizontal track. We calculate the work done on the train during this part of the journey. So how we are going to calculate the work done? So work done formula is already given over here. So we have given all the formula here. The work done is force multiplied by distance. The distance is given here 4 kilometers. We have to convert that into the meter, and the force is already given, that is 360,000. So that we can write down. So we can write down here the formula for the work. So work is nothing but the force multiplied by the distance, and the work we have already given, which provided with the value, that is 360,000, that we can write down as 3.6 multiplied by 10 raised to 5. So this way we can write down 10 raised to 5, and the distance given is, that is nothing but 4 kilometers, that I can write down 4,000 meter. So because everything will be the SI system unit, so if you calculate this value, that 3.6 into 10 raised to 5 multiplied by 4,000, that will come out to be around 1.4 multiplied by 10 raised to 9. So this is the value we are getting over here for the work. And the unit of the work is joule. We are